Hello everyone, what is the result of this operation? That's the question being asked. So how do we solve these kinds of questions? We use the rule here. Guys, what do we mean by this? Look, pay attention. There are two nested roots, and if there's a 2 in front of the inner radical, we use this rule. Are we clear? Now, I'm going to take one of these and let's solve it in a comfortable space. Together, we said square root of 15, then I took the root again. Now, we're going to factor this 15. I'm going to multiply it by two numbers in such a way that their product is 15, and when I add them, I get 8. Now, if we say 15 and 1, multiplying 15 by 1 gives us 15. If I add them, I get 16, which doesn't give me 8. So, the most suitable numbers will be 5 and 3. Guys, I think we're good up to this point. Now, here's what we're going to do. We've factored it, right? Starting from the largest number, you write them inside the root. Root 5. Here, our operation is subtraction. I wrote square root of 3. You guys are awesome. Isn't this the same thing, guys? Yes, so it's the product of 5 and 3. So look, here in this operation, we have addition. I'm writing this. Here, what am I doing again? I started from the largest number, square root of 5. I see that the operation inside is addition. I wrote that down, and I'm saying square root of 3. That's it. The question is already finished. Negative root 3 and positive root 3 cancel each other out. There are 2 square roots of 5 here, guys. So our answer will be 2 root 5. That's all. Hi guys, the question is, which of the following is this expression? That's what was asked. So this is the rule we use for these kinds of questions, guys. Now, what's the important point here? Look, there are 2 nested roots just like this. The coefficient in front of the radical inside needs to be 2. I solved a question similar to this to explain this rule. In that question, the format was exactly like this. I also solved the question just by applying the rule. Alright. There's a small detail here. There are 2 nested square roots. Yes, the coefficient of the radical inside is 4. What do we want it to be? 2. We could only apply this rule in this way, right? So what do we do then? We adjust the expression here. How? So that the coefficient is 2, okay? The coefficient of the root here needs to be 2. Let's start now. Let's see. I can write 4 as 2 times 2. 4. Let's open up the 5th root nicely like this. Leave 1, 2 outside. Let our coefficient be 2. Send the other 2 inside the root. Let's see. This will go in as 4, right? It will go in as its square, into the root. From here, 4 came. If I tidy it up now, look. 9 minus 2 root. 5 times 4 is 20. Super. We added another root like this. Exactly. I've reached this format now. Yes, so what do we do now? For 20, friends, we're going to factor it. But I'm going to multiply it by 2 numbers so nicely that when I multiply them, I get 20. And when I add them, I get 9. The most suitable numbers for this are 5 and 4. 5 times 4 is 20. Add 5 and 4 together. 9. The question is done. What are we doing? Of course, we start with the bigger number. There's no single one. I wrote negative for the operation inside with 5. Let's simplify root 4. The square root of 5 stays. The square root of 4 is 2, friends. Therefore, our answer is square root of 5 minus 2. Hello, friends. Which of the following is the value of the expression? Was asked. So, in these kinds of questions, if the root's degree and the exponent of the number inside aren't the same, friends, look, I've left a note for you. The upper exponent is cut off. We can take it out in such a way. So if you apply these rules exactly, let's start like this. Look, I took the x here. I wrote the exponent of the number inside, 2, in the numerator. I wrote the degree of the root in the denominator, guys. Okay, got it. Now pay attention here. The number inside is x, the exponent is 1, and the degree of the root is 2, so it will come out as x to the power of 1 over 2, divided by x to the power of negative 1. Now, friends, this expression in the denominator, I can move it to the numerator. All right? How? I'm writing x up here. Look. There's just one difference here. Now, since the exponent here is negative 1 and I'm moving it to the top, meaning I'm changing its original place, the exponent will now be positive. Are we clear? Great. Now look, pay attention. Our bases are equal. Do you remember when multiplying exponents? If the bases are the same, we add the exponents when multiplying like this. Right? Great. So what do I do then? Now, 2 over 3 plus 1 over 2. I say plus 1. Here, we're going to find a common denominator as well. Guys, let's call this 1. You can expand all of them to the nearest 6. So let's multiply this by 3, and this one by 2. Now, let's start. 2 times 2 is 4. I'm writing it from here, guys. 3 times 1 is 3, and 6 times 1 is 6 over. Our denominator became 6, guys. Now, if we add up the top, I added 6 and 4. 10, 13 over 6 will come. So, what's our answer?
Done?
I vote a common base. My exponent, it turns out to be 13 over 6. That's it. Hello everyone, we're going to look at a question about radical numbers. What is the result of this operation? That's what was asked. So, we'll start by simplifying the numbers inside the previous root, right? Guys, what is this part? The ninth root of 27. Well, 27 is 3 cubed, so the ninth root of 3 to the power of 3, guys. Plus, the 15th root of 3 means 3 to the power of 5, guys. 243 minus the 6th root of 3 squared. That's what it means. Now, when working with radicals, we paid attention to making sure the exponent inside the root matched the degree of the root so that the number could come out as a whole. Right? Yes, but if they're not the same, guys, how do we take it out of the root? I left a little note here for you. So, what did we do, guys? We took the exponent of the number inside the root as the numerator and the degree of the root as the denominator. In the same way, look, if the exponent is a fraction like this, I can also write this expression as a radical. Now, doesn't our question fit this? Our question, let's try using it. What will you say for 3 to the power of... We say 3 to the power of 3 over 9 plus 3 to the power of 5 over 15 minus 3 to the power of 2 over 6. Now, if you do a little simplification here, like this, all of these will cancel out. It became 3 to the power of 1 over 3 plus 3 to the power of 1 over 3 minus 3 to the power of 1 over 3. Now, pay attention, guys. These two are the same, so they will cancel each other out. What can we have left? We're left with 3 to the power of 1 over 3. Now, there isn't anything like this among the choices anyway, so it means you need to convert it. What is it? We convert it back to a radical number. How do we write it? You say cube root of 3. That's it. Hello again, guys. We're going to pick another radical number question together. Now, I specifically choose these questions because when the degree of the root changes, how do we get rid of the roots? Friends, I'll try to explain this to you as much as I can. To you, if you get the hang of this topic in these kinds of questions, you'll be able to solve similar questions very easily as well. Without dragging it out, address the question. They're seeking the value of x. Simplify the equation. Let's move one side to the other as a negative. Now, what do we have left? The cube root of x equals 4. Friends, to get rid of the root, you need to raise both sides to the power of the root's degree. So, since the root's degree is 3, the power should also be 3. Are we clear? If the root's degree was 4, I would say 4. If it was 5, I would say 5, so we can get rid of the roots. Are we clear? Great, so you raise it to the power according to the root's degree. That's it. So, what happened now? We've eliminated the root from x. Now we have x left. From here, we get 4 cubed. Guys, this will also be equal to 64. They asked us for the value of x. Here, x is 64. That's it. Hi everyone. Now we're going to look at an ordering question about radical numbers. They asked us to show the correct order of the expressions here. Okay. Now, guys, when you're ordering radical numbers, you bring the numbers outside the root inside the root. Let's get started now. 3 will go inside the root as 3 squared. There's a times 2. 3 times 3 is 9. From 9 times 2, the value of it will be root 18, be square root of 21. Square root 21. Now let's arrange C as well. If you bring 2 inside the root, it will be 2 squared times 3. 2 times 2 is 4. From 4 times 3, C will be root 12. Now you can do the ordering. The smallest number inside the root. Since it's 12, C will be the smallest. Then comes A, right? A will be smaller than B.